This is a TI calculator video for Module 10 group work. We're studying inference for means, and these calculator examples cover pages 195 to 196. The question on page 195 has you comparing the average height of 18-year-old American women with sample data collected from a local high school. So we're going to press Stat. We're going to arrow over to Tests, just like we did in Module 9, except now we're going to use a t-test for sample data. And then because we're given the statistics, we're given the means and the population standard deviation, we're going to enter this under Stats, so make sure Stats is highlighted. And the next question, we'll enter the data ourselves in List 1 and List 2, so we'll highlight the other choice data. But for this question, make sure Stats is highlighted. So we put our population mean 64.2 into the mu sub 0, that's the population mean, and that's what we're going to compare to for our null hypothesis. Remember, the null hypothesis means no change, so we're looking to see, does our sample mean differ significantly from the population one or not. And then down here we've got x bar. So when we put this in our calculator, we put in our sample mean for x bar that we collected, 63.1. And then the sample standard deviation, 2.4. We don't want to divide it by the square root of 78 like you will in step 2 because the calculator is going to do that for us. So we'll put in here the population standard deviation, and then we'll let n equal 78 because that's the sample size. In this question, they ask about the difference in heights, and so we want to highlight mu is not equal to mu naught because we're just asking about a difference, and then we'll go ahead and choose calculate. So if we look here, we get a t-value bigger than 2 or bigger than -2. So this is telling us it's more than 2 standard deviations below the mean because our local high school students were not as tall as the mean. And then our p-value is 1.22. E -4 tells us we move a decimal point 4 places to the left. So this is much smaller than 0.05. And so this is a statistically significant result. So let's go look at how to set up number 3 on page 196. In this question, you're given the unlogged and logged data. So we're going to go over to tests. And this is 2 samples, so we're going to choose 2 sample t-test down, choice 4. And now we're inputting the data, so we're going to highlight data. And then we've got to make sure our lists are in list 1 and list 2. So we're going to press stat again, enter to edit, and I'm going to clear out the data I have in list 1. Remember, highlight list 1 and press clear. And I'm going to do the same thing to L2, so remember, highlight list 2, press clear, and make sure you hit enter at the end. And so for list 1, I'm going to put in the unlogged data, following the directions. So I'm just typing those numbers as I see them. And then for list 2, we're going to put in the log data. There's less log data, that's fine. It's okay to have different sample sizes when you're comparing 2 means. Just like with 2 proportions, we could have different sample sizes. It just means n1 and n2 are going to be different numbers. So I am entering my data just as I see it. And notice I'm going real slow to make sure I don't make any mistakes. The most common mistake students have when they're doing a hypothesis testing on their calculator is that maybe they skipped a data point. All right, so now all of our data is in list 1 and list 2. So we're going to press stat. We're going to arrow back over to tests, and we're going to choose choice 4, the 2 sample t-test. We're going to press enter, and we've got list 1 in L1 and list 2 in list 2, so we're all set there. Make sure frequencies are only at 1 because we want to count each data set just once. And the question is asking, is the mean number for the unlogged trees significantly higher than those of logged trees? So remember, the mean of the unlogged trees is going to be associated with list 1 because we put unlogged trees in list 1. So that's saying, is mean 1 greater than mean 2? Always leave pool on no. And then we're going to arrow down and choose calculate. And it gives us our t-value is 2.11, so that's a little bit bigger than 2 standard deviations. And our p-value is 0.0259, this would round up to a 6. And so this tells us that this is a statistically significant difference. If you scroll down, you can see they calculated the means for each of the lists that we put in, and also the sample standard deviations. And we can see the unlogged list had sample size 12, and the logged list had sample size 9.